So today we're going to be dealing with planes, and before we start into the question, I'll ask what is the difference between oblique planes and simply inclined planes. So in the question today we're going to be dealing with oblique planes. The question is going to deal with finding the true length of a line of intersection between two oblique planes. From this then, using our true length and of the line of intersection, we can find the dihedral angle between the two planes. So today we're going to find the line of intersection between two oblique planes and then find the true length of this line. Where would we have done an activity like this, finding a line of intersection and then in turn its true length? Okay, so to start off the question, we're going to first label our traces. So our first trace here, I'm going to label it this top point, point V, the point resting on the XY axis, point T, and our final point, point H. And then on the second trace, I'm going to label top point, point V1, on the XY line, T1, and our last one, H1. So after that then, we're going to extend our traces until they intersect. So I'm just going to start off with our first trace and extend that line out. So we have a new point here, and we're going to label this point Q. Now on the bottom part, we're going to extend our traces also. This time we're going to have to extend both traces. Now we have another new point where these traces intersect, and I'm going to call this point P. So now once we've that done, we can transfer our point P and Q perpendicular to the XY line. I'm going to draw this in red to highlight it. It's very important that these lines are perpendicular to your XY line. So both lines perpendicular. Okay, now from this, our point P and Q, what can you realize about, or what can you see about these 2 points? So both of these points are resting on our vertical and our horizontal plane. So point Q on our vertical, point P on our horizontal. From that then, we're going to join point, we're going to label new points. So our red line here, P1, and our second red line, Q1. Now what we'll do is, in blue, I'm going to join P1 to Q, form a new line, and Q1 to P. What do you think these 2 lines are now? So these lines are our lines of intersection. So these lines represent where both of the oblique planes intersect. From this now, we can start to find our true length of lines of intersection. In order to do this, you'll have to use the compass and a 90-degree set square, 90-degree angle. So take our compass and put your fixed point on point Q1, like so. And then set your arc to radius length of this red line here. So your lead on point Q. And then swing your arc down past the XY line. Now what I'm going to do, I'm going to draw a line from point Q1 perpendicular to our line of intersection in our plan. This line is going to extend out to meet our curve radius Q1 to Q. Now I'm going to label this new point here Q2. So from Q2 to point P, I'm going to join up with a straight edge, like so. What is this new line now? So this line is now our true length. It's our true length because, as you can see here, we have a right angle triangle and our true length is our hypotenuse. So when the right angle triangle stands vertically underneath the line of intersection, you then rotate it using our curve here down till it is parallel to our other true length to get our line of intersection.